In our next section, we are going to talk about the Ospf optimization. In the first lesson of Ospf optimization, we will discuss route summarization, which we mentioned earlier in more detail. Route summarization is an important parameter for scalability in Ospf and helps us solve two important problems. The first problem is large routing tables, and the second is frequent LSA flows through the autonomous system. When a route is lost in each area, the routers in the other area are also required to perform the shortest path calculation. Route summarization can be done on the ABR or the ASBR to reduce the area database size. With route summarization, ABRs or ASBRs combine multiple route information into a single route. Route summarization directly affects bandwidth, CPU power, and memory resources consumed by Ospf routing. With route summarization, only summarized routes are propagated into the backbone area, which is area 0, and the stability of the network is enhanced. Here is how we can summarize the routes on the ABR. The commands we are using on ABR to summarize the routes is area and area ID and range. This is the more important thing we need to focus. Then we use the IP address and a mask. We are going to take a look on an example too. If we want to summarize on ASBR, which is router 1 for this example, the thing we are using is the summary address command this time. Here, as you can see, that we have 002 1520 routes on the external AS domain, which is EIGRP. And if you want to summarize these routes on router 1, we are using summary address and the IP address, mask, and that's it. And let's take a look to the Ospf virtual links right now. Normally, guys, when designing Ospf, each area must be associated with area 0. A design like in the figure cannot be done for Ospf, but if areas cannot physically connect to each other, a solution can be used temporarily. In such a case, the route table of router 3 and router 4 does not see the network connected to the Ethernet interface of router 2. For this, the virtual link between router 3 and router 2 is configured as shown. As you can see in our figure, that's the backbone area. Area 1 is directly connected to here, but area 2 is not directly connected to backbone area, and it's directly connected just to area 1. To resolve this problem, we need to use Ospf virtual links, and the configuration is made on the router 3 and router 2. We type router Ospf and the process number, and we define the area 1, this area, which is directly connected to area 0 on both routers. Then we type virtual link and the router ID of the neighbor router. For router 3, we are typing the router ID of router 2, and for router 2, we are typing the router ID of the router 3. And if you want to verify the virtual links, we can use show IP Ospf virtual links command. The Ospf stub and totally stub structure was developed to reduce the size of the Ospf database and the routing table. For example, on router 1, if we type show IP route, it can be seen that even the route records from the RIP network, this guy, are in the routing table of router 1. However, router 1 does not need this route. It only inflates the routing table of the router 1. Normally, we can solve this problem with the default route or etc., but our goal is to solve with Ospf. To solve this problem, stubby and totally stubby area configurations must be done. Stubby area, this guy, blocks type 5 LSAs, which means LSAs from external networks such as a RIP or RIP or AIGRP or something like that. And totally stubby area blocks the type 3, 4 and 5 LSAs. And let's check how we can configure the Ospf stub area. Let's take a look to the router 3 configuration first. The Ospf configuration of router 3 is router Ospf and our process number. Then we advertise our networks and we are using area number, which is area 2, and stub. Whenever we type this, the neighborhood between router 3 and router 4 is down, unless we configure the Ospf stub flag on router 4. And to configure the Ospf stub on router 4, we are typing the same thing. We just type area number and stub, and that's it. And let's take a look to the Ospf totally stubby area configuration. To configure a totally stubby area on router 3, which is an AVR, we type area number, and this time we type stub no summary instead of stub. But in router 4, we are typing again area number and just stub. And these configurations make area 2 as totally stubby area, and we block the type 3, 4 and 5 LSAs in this area. Ospf, the NSSA, allows the external routes outside the Ospf autonomous system to be advertised in the Ospf autonomous system. ASPR is found in NSSA and external networks flood in NSSA with ASPR type 7 LSA. The ABR, which communicates the NSSA with the other areas, does not allow the transmission of type 7 LSAs. It receives and converts them into type 5 LSAs and transmits them to the other areas, allowing the Ospf autonomous system to learn the external networks of the other areas. And here is how we can propagate a default route in Ospf. If you want to propagate a default route in Ospf, we type router Ospf and process number, and here is the command for propagating. Default information and originate propagates a default route to other guys in Ospf domain.